Alright, time to do the B question because yes, we just did the A question and we know that A equals 2. So the B question is asking for the equation of PQ, which means the line equation of PQ. We know line equation as this, y equals mx plus c. So we're trying to find that of the PQ line, right? Which is this line right here. If this pen would just comply for 1 second. Okay. Alright, so we're trying to find the line equation of that. But in order to find a line equation, we have to find a gradient. And right now we only have a single coordinate, so finding the gradient is pretty much impossible. So we're gonna find the P coordinate because, well, we already have the gradient of this line and we already have two coordinates that we can work with. We can choose either one. And so we can reverse the gradient formula to get the P value. Now, something to noteworthy to mention about P is that it is a y-intercept coordinate, meaning it is a point on the y-axis. What that tells us is that its x-axis is 0, because on the y-axis it is 0. And its y value is just something, and we're trying to find that out. So, when we plug it in the reverse gradient formula, we get something that looks a bit like this. Y minus 3, the y from the P coordinates y value, as we don't know that yet, and 3 from, as we're using the T coordinate to substitute into the equation. So y minus 3 over 0, which is the x-axis of P, minus 2, as we know from the previous question's answer, A equals 2. And then we plug in negative 1 over 2 because we know that the gradient of PTR is negative 1 over 2. So 0 minus 2 is, well, negative 2, because yeah, y minus 3, we don't know that yet, equals negative 1 over 2. When we move negative 2 over, negative 1 over 2 times negative 2, the negatives cancel out, and 1 times 2 is just 2 over 2, which just means 1. So that's how we get 1 right here. So y minus 3 equals 1. We move negative 3 over, it becomes plus, and we end up with y equals 4. So now that we know that the y value of P equals 4, we can rewrite it here. Alright, so now that we know the coordinate of P, we can get to solving the gradient of the line PQ in order to fulfill the line equation. Alright, gradient. What was the gradient formula? Well, m1 equals y2 minus y1 over x2 minus x1. So let y2 x2 be the P coordinate, and that will be 4 minus the 2 of the S coordinate, and 0 minus 3 of the S coordinate. As you can see right here, the S has a negative 3. 4 minus 2 over 0 minus 3. That gives us 2 over 3, because minus right next to each other means that they turn into a plus, right? So now that we know the gradient is 2 over 3, we can put that in the line equation. Y equals 2 over 3x plus c. Now, I am almost 100% certain that the y-intercept is 4, as it's the line here, it hits the y-axis at P coordinate, which means that it's 4. But since we're not confident that that's the truth, we're going to be using the substitution method to prove that that is absolutely true. So we're going to be using the S coordinate to test that out. Substituting the S coordinate into the line equation would turn it into 2 equals 2 over 3 times negative 3 plus c. 2 over 3 times negative 3 equals to negative 6 over 3 plus c. Negative 6 over 3 plus c just means negative 2 plus c. And since we want to figure out what c value is, we move -2 over 2 plus 2 equals c. And for those who are confused, the 2 is always here. The 2 is always here. 2 plus 2 equals c, 4 equals c, which was the x coordinate of p. So yes, c equals 4. And so your final answer should look like this. Alright, so I'm gonna rewrite the answer to question 1 just in case it becomes useful. Alright, now it tells us to find the coordinates of Q. Now, what do we notice about Q? It is a coordinate that lies on the x-axis, as you can see right here. Well, that tells us that its y value is 0. So it's x, 0. It's on the x-axis. It crosses over the origin of the x line, which means that its y value is 0. Yep, we understand that. So we can do the same thing as how we used to find out the value of p, and that is by putting in the reverse gradient formula to find the coordinates of a certain coordinate. Now, as we know that the gradient is 2 over 3, let's rewrite it as 2 over 3 equals, we're going to be using the s coordinate to substitute into the gradient formula. So 2 of the s coordinate minus 0 of the q coordinate, -3 of the x coordinate minus x of the, well, q coordinate. Now, what we do is we move the -3 minus x over. That will give you using the FOIL method, we can times the value with the contents inside. Now that will give us -6 over 3, and 2 over 3 times x equals negative 2x over 3 equals 2. Now that we have this, we can switch these two values to give us, well, we know that -6 over 3 is 2, so -2 minus 2 equals 2x over 3. That leaves us with -4 equals 2x over 3. We move 3 over. 3 times -4 is -12 equals 2x. X equals -12 over 2. X equals -6. And we can kind of tell ourselves that this is true because the q coordinate lies behind the y-axis line. It lies behind, and so its x-axis is definitely to be in the negatives. Just a short note to convince yourself that, yeah, your answer is probably correct. So now that we found that x equals -6, please remember about what the question is asking. It's asking you for the coordinates of q. So when you're during a test and you found x equals -6, don't leave it like that. Please, please, please remember to write it down, -6 over 0, and then you can do this so the teacher knows that that is your final answer. So we now know that q equals -6 and 0. Right, I can erase all of this. This video is gonna be so goddamn huge. Alright, final question, perimeter of PQR. Alright, this is probably the easiest question, but also some people might forget how you're supposed to do it. Finding the perimeter of PQR means that we're finding the perimeter of this triangle, right? We're finding the perimeter of this triangle. That means we're finding the length of this line, and of here to here. We know that from 0 to O to Q is -6, as we know that the x-axis, the x value of Q is -6. And we know that since r is 8 equals 0, it means that the length here is 8. Since we're calculating the total length, 6 is just going to be positive for what we're about to do. 8 plus 6 equals 14. Do bear in mind, the x-axis is definitely still -6. It's just that we're finding the total length of this line, so we'll just be using 6 as a positive. So now that we know that the bottom line of this triangle is 14 units. Alright, how do we find these two lines? Well, we use the Pythagoras theorem, as these two are actually right angle triangles. We know that this line right here, for this specific triangle, is 8. We know that since the x-axis of P is 4, that this line must also be 4. So now that we got base times base, which is 4 and 8, you can plug in square of 4 squared plus 8 squared equals this line right here, which we will be calling PR. Very helpful, sir. And then we'll also be finding this, and since we know that Q is -6, we'll know that this is 6, and the line is still the same, so it's 4. So we'll plug it in like so to find the length, and we know that, let's just call it PQ. So let's use a calculator to find PR as equals 4 times square root of 5. We'll be writing in this so that we get the final answer to be as accurate as possible. I advise doing this during your tests. It helps out a lot. 2 times 13. So now that we know the length of these two lines, we can get the perimeter of the triangle. We know that the bottom line is 14. We add 4 times 5. Sorry, 4 times square root of 5. And then you just plug it all into your calculator. Do make sure that you're plugging in the exact same way as I've written it out. And you'll get 30.15 as your, final answer. I'm just going to double check that I didn't get it horrendously wrong. Where is it? Let me check. Alright, so no, I'm not wrong. It's just 30.16. Alright, hope you learned something. That will be the end. That being all the questions answers.